Hi guys! So here we'll be learning from me how to recognize and draw the Fischer projection. Let's take a look at this molecule. I'll be using as example R-bromochloroiodomethane. Chemical formula CHCl-Bri. With one carbon in my hand, there's a molecule. The one in the middle that's black. The one that's green. Can you see the screen? This is your bromine. White must be the hydrogen. Orange here, that's a bit smaller, that's chlorine. And the bigger red one, that's iodine. So this molecule is chiral because we have a carbon that connects to 4 different groups. Now, how do we know it's an R isomer? We have to arrange them by the priorities using the Karn-Ingold-Prelog rule. Hydrogen must have the lowest priority, so you put this bond towards the screen, facing the back. And now you assign the rest of them. Iodine has the highest atomic number, it must be number 1, followed by bromine, number 2, and chlorine, number 3. And what you see now is you have a rotation of 1, 2, 3. That is clockwise. So clockwise means it is R. So how do we represent this in a Fischer projection? Now for Fischer, you see that it's always just lines, There's no wedge bonds or hash lines. But when I see this, chemists like us, we know that this translates to that. What it means is, for the horizontal line, the bonds are actually wedge bond. Means it point at the angle towards you, this way. So in terms of a molecule, you'll be looking at something like this. Do you see that? Your chlorine and your bromine are pointing at you, whereas your iodine and hydrogen are slightly to the back, that's closer to me. Do you see that? So if I put this molecule statically, this translates to iodine. At the bottom is hydrogen. To the side, there's a bromine. And the left, there's a chlorine. In terms of the 3D, you notice that it's the same. Iodine goes a bit to the screen. Hydrogen goes a bit to the screen. Side, bromine goes towards you at the angle. And on the left, there's chlorine. Right, chlorine. Yeah? Now, what if we rotate the molecule and see this way? Notice I didn't calculate any bonds or change the relative position of each atom. It's still the same molecule, but we can redraw this. Again, first of all, you draw a cross, and then you see. Now, H is on your left. Right side is iodine. Top, there's a bromine. And bottom here, there is a chlorine. These two might look different, but they represent the same molecule. And from here, you could actually know that they are the R isomer. Okay? Next, let's draw it. What about I flip to the opposite side? Okay? So here is iodine. H top, that's a chlorine. Bottom is a bromine. See that? See that? Can we draw some more? Can we draw some more? Can we have an iodine at the bottom? Sure. Let's give it a try. Again, across first, iodine now, I want it to be at the bottom. Notice that I can't put it this way because the Fischer projection says that the horizontal bonds must be pointing closer to you. But now, if you look at my diagram here, these two are pointing to the back, so I need to rotate. So this way, you have iodine pointing down, and yet it's closer to me. So look here. I at the bottom, top must be Br, side here H, and left Cl. So try to practice and understand that all these 4 different Fischer projections represent the same molecule, R-bromochloroiodomethane.